Picture this. You're stationed at a base camp in Everest City. During the day, it's a brisk 12 degrees Celsius, but overnight, the temperature completely plummets, dropping by a massive 18 degrees. So how do you mathematically calculate exactly how freezing you're going to be when you wake up? Well, welcome to today's Explainer, where we're going to master operations on integers so we can solve exactly that kind of real-world mystery. Okay, let's dive into this digital notebook. We've got 5 quick steps for today's lesson: adding integers, subtraction and inverses, multiplication rules, evaluating expressions, and finally, real-world challenges. By the time we wrap this up, negative numbers are just going to be another perfectly normal tool in your mathematical toolkit. All right, section 1, adding integers, building the foundation. Let's get into it.
Adding integers is the bedrock of literally everything we're going to do today, so we've got to lock down these rules right from the jump. I want you to draw a mental box around this absolute value strategy because it's absolutely vital. Here's how it works. If you're adding 2 integers with the same sign, you just add their values and keep that sign. Super simple, right? But if they have different signs, that's when you find the difference between their absolute values, meaning you just subtract the smaller number from the bigger number without even worrying about the signs for a second. Then, the result takes the sign of the number that had the larger absolute value. Basically, the bigger force wins.
Let's put this into practice immediately. Here's a quick knowledge check straight out of the lesson material. Try to evaluate -5 plus 3. I really want you to be an active participant here, so go ahead and pause the explainer right now, grab some scratch paper, and apply that rule we literally just learned. Okay, let's write out the solution together, step by step, just like we're working in a real notebook. Step 1, we recognize we've got different signs here, a -5 and a +3. Step 2, we find the difference of their absolute values. The absolute value of -5 is 5, and the absolute value of 3 is 3. 5 minus 3 equals 2. Now, step 3, and this is the absolutely crucial part. Why do we keep the negative sign? Because the absolute value of -5 is greater than the absolute value of 3. The negative side is stronger, so we attach that negative sign right onto our 2. Our final boxed answer is -2.
Moving right along to section 2, subtraction and additive inverses, flipping the script.
Now I have to give you a bit of a warning up front. Many students make a mistake in this step. Subtraction with negative numbers can feel a bit like a brain teaser, but I'm going to give you the golden rule to make it completely foolproof. Here it is. Subtraction is just adding the additive inverse. If you see a minus b, you should immediately rewrite it as a plus -b. You change that subtraction sign to addition, and you flip the sign of the very next number. By turning every single subtraction problem into an addition problem, you can just fall back on the absolute value rules we just mastered. It's a total game changer. Time for another knowledge check, and listen, this is a common exam question taken straight from your classwork. Try to evaluate these 2 expressions, 5 minus 6 and 4 minus -6. Go ahead and pause the explainer, write them down, and practice flipping those subtraction signs into addition. Let's see how you did as we walk through the steps. For the first example, 5 minus 6. We apply our rule. We keep the 5, change the minus to a plus, and change that +6 to a -6. So we get 5 plus -6. Using our addition rules, the difference is 1, and since the -6 is larger, the answer is -1. Now, on to example 2. Be careful here. 4 minus -6. We change the minus to a plus, and that -6 flips to a +6. So that double negative magically transforms into a positive. It just becomes 4 plus 6, giving us a highly satisfying final answer of 10.
And you know, this brilliantly illustrates exactly why you cannot treat subtraction the same way you treat addition. Addition is commutative. That means a plus b is exactly the same as b plus a. But subtraction? No way. If you try to flip 3 minus 5 around to 5 minus 3, you are going to get totally different answers. 3 minus 5 gives you -2, but 5 minus 3 gives you +2. They are not equal. The big takeaway, never flip the order in subtraction.
All right, on to section 3, multiplication rules and properties.
If subtraction felt a little tricky, go ahead and take a deep breath, because the rules for multiplying integers are wonderfully straightforward. You'll want to lock these into your mental notebook. If you are multiplying 2 numbers with the same sign, like 2 positives or 2 negatives, the product is always positive. If they have different signs, 1 positive and 1 negative, the product is always negative. And of course, anything multiplied by 0 is just 0. Easy, right? Now, let's see a quick trick using the distributive property. Look at this expression,
5 times 7 plus 5 times negative 7. Now, you could do the multiplication first, getting 35 plus negative 35, but watch how we can streamline this. We can actually factor out that common 5. Step 1. We rewrite the whole thing as 5 multiplied by the group of 7 plus negative 7. Step 2. Take a look at what happens inside those parentheses. 7 plus its additive inverse, negative 7, is just 0. So step 3, 5 times 0 is 0. We completely skip the hard math just by understanding our properties.
Almost there. Section 4, division and evaluating expressions. So division follows almost the exact same sign rules as multiplication, but it does have a few unique quirks we need to respect. First, just like multiplication, same signs yield a positive quotient, and different signs yield a negative quotient. But here are the two big differences you gotta know. 1. Division by 0 is undefined. It is literally mathematically impossible. And 2. Division is not closed in z, which is just the fancy math symbol for integers. That basically means if you divide two whole integers, like 5 divided by 2, you aren't guaranteed to get a whole integer back. Sometimes you get a fraction or a decimal.
Let's test your ability to put everything we've learned so far together. If a equals 6 and b equals negative 2, find the value of the expression 4a divided by 2b. Quick tip, remember to use parentheses when you substitute those numbers in. Pause the explainer and give it a shot.
Let's walk through the solution steps together. Step 1 is substitution. We replace a with 6 and b with negative 2. The crucial thing here is to evaluate the multiplications first. So we have 4 times 6 divided by the group of 2 times negative 2. Step 2, let's calculate those products. 4 times 6 is 24. 2 times negative 2, well, they have different signs, so that gives us negative 4. Step 3, we're left with 24 divided by negative 4. A positive divided by a negative means our final answer has to be negative. 24 divided by 4 is 6, giving us a final answer of negative 6. Excellent work if you got that.
Finally, Section 5. Real-world integer challenges. Let's see how all of this actually applies.
This is the fun part, where math steps off the page and into reality. We have a scenario about the temperature dropping in Everett City, and another one about a submarine diving deep underwater. Our job now is to translate these everyday English sentences into the integer math we've been practicing.
Let's solve that mystery from the very beginning of this explainer. Everett City starts at a maximum of 12 degrees Celsius. Then it drops by 18 degrees. Drops translates to subtraction. So we write down 12 minus 18. Applying our golden rule of subtraction, we immediately rewrite this as 12 plus negative 18. They have different signs, the difference between them is 6, and since the negative 18 is larger, we keep the negative. So, the new temperature when you wake up is a freezing negative 6 degrees Celsius.
Next up is the submarine problem. It reaches a depth of 120 meters underwater. Now, depth means it's below 0, so our starting integer is negative 120. Then it rises 50 meters. Rise means addition, so that's a plus 50. Our equation is negative 120 plus 50. We have different signs, so we subtract the absolute values to get 70. The negative 120 is the larger absolute value, so our answer stays negative 70, meaning the submarine is currently sitting at a depth of 70 meters.
Let's step it up with one last multi-step challenge. It's not just a single addition or subtraction problem anymore. We actually have to combine addition with multiplication to track a moving object over a period of time.
Let's map out the logic here, line by line. Step 1 is finding the initial position. It starts at a depth of 95 meters, so we write down negative 95. Step 2 is calculating the movement. It rises for 30 minutes at a speed of 5 meters per minute. To find the total rise, we multiply. 30 times 5, which equals a positive 150 meters. Step 3 is combining them. Negative 95 plus 150. We find the difference, which is 55. And since the positive 150 is the larger absolute value, the answer stays positive, so 55 meters. That means the submarine didn't just reach the surface. Mathematically, it theoretically shot 55 meters straight into the air. Or, more likely it's just measuring an altitude above a specific sea level datum. Either way, our math is flawless.
You guys have done incredible work today, mastering absolute values, additive inverses, and the rules of signs. But before we officially sign off, I want to leave you with one final test of your new skills. Imagine you're in Alpine Village. The temperature starts at a chilly 8 degrees Celsius and then drops by 14 degrees overnight. Can you apply today's rules to write out the equation and solve this final homework challenge completely on your own? Grab that notebook,
Keep practicing, and I'll catch you in the next lesson.